Hello, my name is Azim Zihad, and I developed an at home ECG device that can read your raw ECG signals in real time. This idea came to me because of my passion and interest in brain computer interfaces. Recently, I wrote an article about synchron stentrode, which you can find on my Medium, which I will leave in the description below. Finally, now, let me show you what I built. As you can see, this is the setup for my project. It involves two parts, the breadboard and the electrodes. On the breadboard, there are two components, the Arduino Nano and the AD8232. First, the Arduino Nano sends information to my computer via USB-C. The AD8232 is what connects to the electrodes. The Arduino Nano and the AD8232 connect via male-to-male jumper cables, which I'll show on the screen right now. The AD8232 connects to three electrodes. The red electrode is the negative electrode. The green electrode is the ground electrode, and the yellow electrode is the positive electrode. So now I have the red one hooked up to my right hand, and I have the yellow one hooked up to my left hand, and I have the green one hooked up to my right leg. After connecting my device, I'm in Arduino IDE right now. In the first few lines, I create a simple bandpass filter. Here, I define an order for the bandpass filter. The higher the order value is, the more complex the filter will be. Here, I add some example coefficients for the bandpass filter. This step is just for extra convolution. Here, there's a buffer for the bandpass filter. What the buffer does is, it applies the filter to every new sample. Here, there's a circular buffer index. What this does is, it helps access old samples and add new samples. I added some more filtering. First, I determined the window size for the moving average filter. Then, I create an array to hold samples. After that, I add an index which is used to add new samples. The void setup function is for when the program starts running. The serial function is just to determine how fast the data is being transmitted. In the void loop section, first, I read the raw ECG signal from A0. This represents the ECG signal. Then, I apply the bandpass filter and the moving average filters I just made. Line 21, this code sends the filtered and smoothed values to the serial monitor. I'll show this value right now. As you can see, it's pretty consistent at 231, 232, 233. And in the next line, I add a delay for smoother plotting. The buffer index is constantly changing since the program is always taking in new samples, so therefore the buffer index changes by 1 per sample. Next, I return the filtered value. In the moving average filter function, it adds a new sample to smooth buffer. In the next few lines, it computes the average. First, what it does is, it initializes a sum variable to accumulate to the sum of all the values in smooth buffer. In line 49, it loops through every element in smooth buffer. Next, it equals sum to the sum of all the values in smooth buffer. Then, the program updates smooth index for the next sample. Then, finally, it returns the smoothest value, which is the average of the sum of all the values in smooth buffer. This is the serial plotter for my program. So this is the accumulation of all the code. Right now, as you can see at the bottom, I have it set to 4800 BAUD. You can also set it to 9600. However, I feel like it's a little less responsive if you set it to 4800, but it's more accurate because 9600 is really fast and a little harder to read. So, as you can see, my ECG signals are pretty consistent at 239 to 242.
Thank you for watching me on my first project of this type, and certainly not my last. This project has been such a big milestone and learning curve for me. Prior to this, I didn't even know basic engineering like Arduino, breadboard, jumper cables. I didn't know how to use any of that. And after this project, I feel confident in the fact that I can use any of these things. It's amazing how much you can learn just from one project. I'm really excited for my next one. Thank you for watching.